All right, section 2.4. We're moving on. And now we are adding tools to your tool belt. So you'll see what I mean by that, okay? Dividing polynomials, remainder, and factor theorem. All right, so basically all of our bullet points are up there. We're going to look at division of polynomials. But the first thing I want to do is just look at regular old division. So let's say we had 2,142 divided by 5. Okay. So my question is, first of all, what is some terminology, and then what is the process we go back when we were in whatever, I guess elementary school, you did long division. So what is what's the process for going and dividing? Let's do that first, and then we'll talk about what this is called and that's called. How do you actually divide? You leave it like this? That's how you were taught to divide? No?
Are you
Yes.
talking about long division?
How I was taught was to find out how many times 5 goes into 21.
Yeah, but you don't leave it like this. How do you write it? The house. 5 outside the house. There you go. Now we're getting somewhere. All right. So you got the 5 outside the house. You got the 2142 in the house. Now, so there, since this comes at the end, that's how it helped me remind that this is the dividend. All right. This is the divisor. Just going through that terminology. Then we'll get to what you said, because you really, in order to do division, you're doing multiplication in reverse. That's exactly what you do. So the first question for Ray is like, well, she looked at the 21 because she knows 5 is not going to go into 2, so she looks at the 21. How many times will 5 go into 21 without going over, right? So get close without going over, and that would be how many? 4. So once you figure that out, then you take this number, multiply by the 5, and you get that answer there. All right? 20. Then you do what? Subtract. Bring down the 1. 21 minus 20 is 1. And then you bring down the next digit, because 5 is not going to go into 1, obviously, because that's what's left over. So then you ask yourself the same question again. 5 times what? It's going to get you close to 14. That would be what? 2. All right, 2 times 5, 10. You subtract again. 14 minus 10 is 4. And then we bring down the 2. All right. 5 times what gets you close to 42? 8. 8 times 5 is 40. Subtract. Now we got a 2, and there's nothing left, and we're not going to do a decimal. We're just going to leave it like this, okay? I'll show you how you can write it. Okay, what is this called? Remainder. What is this called? Quotient. All right. So when you do a division, dividend divided by divisor, you always write your answer like this: quotient plus remainder over divisor. That's what gives you your decimal. That's what tells you the fraction that's left over. Okay. All right. So for this problem, 2142 divided by 5, we should get 428 plus 2/5. Well, if you type this in on your calculator, 2142 divided by 5, you're not going to get 428 plus 2/5. You're going to get 428.4. Well, where does that 0.4 come from? That's the 2/5. Okay. So So that's how it tells you what this represents what your decimal is. Okay? And that's normal long division. Okay? All right. Everybody good with that? I don't think we're just doing one as a refresher to just remember that division is really asking what multiplies to get you close, like what Rayleigh said. So we're gonna remember that. But our goal today is not to do regular long division. Our goal is to divide what? Polynomials. So there's two ways that you can divide polynomials. There's two processes. One is called long division, one is called synthetic. Okay, which one is better? Synthetic, but we're gonna review long division because you can't always do synthetic. So long division says this. So now we'll look at a long division problem of a polynomial. So let's say I have x squared minus 5x plus 3 divided by x plus 1. Okay, let's just say that's what we have. So would you agree that that's division of polynomials, that those are both polynomials? Yeah. All right. But the process is the same. So the reason I want to do this right next to this problem is that we set it up the same way and we work it pretty much the same way with the multiplication and the subtraction. So the first thing we're going to do is we're going to go ahead and put that this is still the x plus 1 is the divisor, the numerator here is the dividend, and we're going to go ahead and put the dividend under the house. Now, the one thing that we do got to remind ourselves, and I'll show you one in a second, is that we need to put zeros for placeholders. Like if we're missing a term, we need to put zeros for placeholders. So we don't have it on this one, but we're just going to put a reminder. Make sure to put zeros for placeholders. Okay? All right. Now, basically what we're going to do is we're going to multiply this x plus 1 by something, and it's going to go under here. Okay? But all I do, my eyes just go to this and this, the first piece here and the first piece here. And I just ask myself, what times the x will give me x squared? Now notice, it will give us something close to this, but it won't be exact. I mean, it could be exactly x squared minus 5x, but it won't. It's kind of the same idea. So you're going to say, okay, x times what would give us x squared? We would say what? X. And once we write that, we're going to go and multiply that by each of those and put that answer down here. Bless you. All right. Okay, so let's see. So we get what? What would go down here?
X squared plus 1x.
X squared plus x. Okay, that goes there. Now, the next thing we did, so once we wrote that 20, after we wrote the 20, we did what operation? Subtract. Now, here's where you got to be careful. You got to subtract this from this. Well, if I just put a subtraction symbol here, it's not negative 5x and x, it's negative 5x minus x, right, which is the negative 6x that you were saying. So what I usually do is this. I don't subtract, I just negate. I negate the whole thing. So I negate this, and I negate that, and then I add. So instead of subtraction, what it is subtraction, I just negate and then combine the like terms. Well, what happens in the first column? What's x squared and negative x squared? Cancels, and that's what should happen each time. Negative 5x and negative x, we get negative 6x. Now, what I always relate to students, if you have two pieces here, you want to have two pieces there. So we're going to go and bring this 3 down. There's that. And now we do the same process again. Again, focusing on the first piece. X times what's going to give you negative 6x, put that there, multiply, put that there, and then once you finish, that should be your remainder. And then we'll talk about how we write our answer. And then I'll give you one more to do. All right, so what goes up at the top? -6. Then I go through and multiply each of those by -6, so I have -6x minus 6. But I'm supposed to do what? Subtract, so I'm gonna negate and add. I'm just putting this. So if I'm subtracting, both of those will turn into positives, and then I'll combine my terms. So there, this cancel, 3 and 6 adds up to what? 9. Now that's done because your x is not gonna go into a 9, okay? And we stop, okay? What is this called? What's this called? Quotient. How do you write your answer? That's exactly right. So we know that x squared minus 5x plus 3 over x plus 1 equals x minus 6 plus 9 over x plus 1. And there's your answer. That's how you write your answer. Okay? All right, we're going to do another one with long division, and then we'll go to our shortcut, which I'm sure you're going to do. I'm going to leave a term off. So you're going to put a 0 for that. So if I don't put an x squared term, you put 0x squared. If I don't put an x term, you put 0x. So that you'll keep your work organized, okay? So let's say we've got (2x cubed minus 4x squared plus 7 divided by x minus 3. All right, so we're going to go ahead. This will be technically our example 1. Divide and write the answer in the form quotient plus remainder over divisor. All right, take a second, see if you can do this one. Use long division, then we'll transfer over to synthetic. All right, did everybody put a 0x in your dividend? Okay, you got to do that to keep your work organized. All right, so what's the first question I should ask myself? 2x cubed, right? X times what gives you 2x cubed? You would do 2x squared. Then you're going to multiply both of these by 2x squared. You get 2x cubed minus 6x squared. And we're going to negate and add. So that is a negative that turns into a positive. So what should you have got after this first line here? 2x squared. And then I'll just bring down the 0x. Okay, just because if I have two, this binomial is going to have to match up with this binomial. All right. X times what gives us 2x squared? 2x. So it'd be 2x squared minus 6x. All right, then I negate and add again. That's a negative. That's a positive. All right. And then we get what? What should you get down here? 6x, and then I bring down the 7. All right. X times what gives us 6x? That would be what? 6. We get 6x minus 18. And the last time here, negate and add 7 and 18 is, oops, I don't know why I did that in orange, 25. So we got our final answer should have been x squared plus 2x plus 6 plus 25 over x minus 3. Now typically, the majority of the division you're going to do is going to be with linear polynomials, x plus 1, x minus 3. You'll understand why. You could do it with a quadratic. It's the same process, but I was going to focus more on division with linear by x plus or an x minus, because that allows us to do synthetic division. Question? Did I mess up somewhere? Yes, 2x. Sorry. Missed that. Thank you. Okay, everybody good with that? Is this, probably didn't do a lot of long division, probably did more synthetic, but I wanted to do long first just so you see it. Long, you can do long division for anything. So if I had a quadratic down here, I could divide by a quadratic. Okay? All right. So now what we're going to do, we're going to look at synthetic. So let's save this answer over here somewhere. Let me just squeeze it in up here. So if I had x squared minus 5x plus 3 over x plus 1, we got x minus 6 plus 9 over x plus 1. Okay. All right, there's that. Okay. So those were the two problems that we did. And we did notice how we use our 0 there, because this helped keep our work organized by using that placeholder. All right, here's what synthetic division says to do. So now for example 2, we're going to do each of these problems that we did, but we're going to use synthetic division. All right, and so we'll start with part A, which is the one that we did previously, the x squared minus 5x plus 3 over the x plus 1. All right. And then we'll talk about, I set mine up maybe a little bit different than other teachers. So if you already had a teacher and they've set it up for a certain way, you're probably going to set it up that way because that's what you're used to. I'm going to set it up the way that I'm used to, but it's pretty much the same. So the first thing you do is just like we did with putting our house, you're gonna first look down here at the divisor and you're going to figure out what makes that 0. And so what makes the bottom 0 is what? So you're not going to put an x plus 1 or 1, you're going to put a negative 1. I put it outside the house like this. I put like a little half a rectangle there, okay? And then you're going to put the coefficients of the dividend in here. And our coefficients are 1, negative 5, and 3. Okay? And here's all you got to, and then I put a line like this, similar. So it's set up similar to how we did our division before, except I'm using the number that makes this 0. And I'm using all those coefficients in there. Here's what you got to remember. Vertically, you add, and diagonally, you multiply. If you can just remember those two things, it's pretty easy. Okay, vertically we add, and diagonally we multiply. And we start with what first? What's the first thing we do? Have you guys had synthetic division before? What's the first thing you?
Forever ago.
We drop down.
Yeah, the first thing you do is you drop down. 1 and nothing, 1. And then you multiply. -1 times 1 is -1, and that goes here. Okay? Then you add, very good. So vertically you add, that's -6. So I want you to look here, and now look at your answer. See the 1 and the -6, see the x minus 6? So I want you to see how this is gonna lead to our answer. So add, then multiply, add, then multiply. -1 times -6 is 6, 3 and 6 is 9, and I put the, another half rectangle like that, and whatever comes at the end is your remainder. And whatever's in here are the coefficients of the quotient. So you just gotta kind of think to yourself, well, if I'm doing an x squared divided by an x, I can see that my quotient has to be an x. To know that this is the coefficient of x. See, the 2 pieces it's linear, 3 pieces it would be a quadratic, 4 pieces it would be a cubic. So the number of pieces tell you it's a linear function. If it was 3 pieces, then there would be squared, because ax squared bx and c. And then now, how do I write my answer? Well, so if it's an x squared divided by an x, this has to be an x, so I get x minus 6 plus the remainder of 9 over my divisor of x plus 1. And that's synthetic division. So, just to do a generic one, just to do like a little formula. If I did a generic, like, just to make a, say I had ax cubed plus bx squared plus cx plus d divided by x minus k, just to do the setup, I want to make sure that we set it up. So if we wanted to set up synthetic division, what would go outside of on the outside? A k, that's right. And then, what are the coefficients that would go inside? A, B, C, D. Not very original there. Then we put a line, and then we just remind ourselves, vertically we add, and diagonally we multiply. And we just kind of snake through there, add, so the A would come down. That would be KA. I'm not going to keep going because half the alphabet will be on the board before we know it. But I just want to kind of give you the setup. Whatever's here is the remainder. And these, remember, are the coefficients of the quotient. Okay? All right. So why don't you try this one here? And now look, you kind of know how it's got to go. It's got to go 2, 2, 6 on the bottom. If you don't get 2, 2, 6 on the bottom, you've done something wrong. And what should you get at the very end? Okay. All right. You can do that. You won't be able to do the entire homework tonight, but you'll be able to do the majority of it. Most of it's division, it's gonna say divide, divide, divide. You just go through and divide. You can skip around and do the ones that we haven't got to yet. appropriate your placeholder. Gonna have that 0 in there, or you won't get a quadratic down here. Okay? So now it's fast, right? Should go by quickly. What are the only two operations you're doing when you do synthetic division? Because for me, subtracting can be a little bit more difficult sometimes than dividing. So I point, you tell me what to write.
6, 18, 25.
There you go. There's your answer. Now, how do I know this is a quadratic? 3 pieces, right? And you know if it's an x cubed divided by an x, think x cubed divided by an x is going to give you an x squared. Okay, so 2x squared plus 2x plus 6 plus 25 over x minus 3. Okay. Any questions about that? All right. If we call this top, this whole top of, I mean, would you agree that that numerator is a polynomial? I could call it a function. I could call it f of x. If I asked you to find f of 3, notice 3 is what we did with the synthetic division. If I asked you to find f of 3, what does that mean to do? How do you find f of 3? If the whole top is f of x, how do you find f of 3? Plug a 3 in. Can you go ahead and do that for me? Do it by hand, see what you get. So if your top is the 2x cubed, your numerator, minus 4x squared plus 7, take a second and find f of 3. Substitution, guys. By the way, there's no coincidences in mathematics. It either is or it isn't. Other than stats, that's all different. Okay. All right, Andrew, what'd you get? Check your work. 25. Andrew got 25. He's right. It's 25. 2 times 3 cubed minus 4 times 3 squared plus 7. All right, this is 3 cubed is 27. 27 times 2 is 54. 4 times 9 is 36 plus 7. So there was your 18. And 7 is 25. You see a 25 anywhere? Is that just a coincidence? Could be sometimes, right? In this case, it's not. It's not a coincidence. That will always happen. So, just to show you a different one here. Let's just say we had, we'll call this one example 3. Let's say we had x to the 4th minus 3x cubed plus 7x squared minus x plus 2, and we were dividing by x minus 4. So it's going to be a big problem. We can do that. But if I think of the whole top as a function, right, f of x, I know before I do anything that the remainder to this problem should equal what, notation-wise? What's that?
F of 4.
That is exactly right. That is a theorem in math. Because we know 4 is what we're going to put outside of our synthetic division. We would use 4. The remainder is always the same as if you had subbed in a 4. So your remainder is always f of whatever you do your division. We'll double check in a second. So let's just do this division real quick. No placeholders, 1, -3, 7, -1, 2. And we know that whatever we get here should be the same as subbing in a 4 up there. Okay. That's going to be a big help as we move on. Okay. I'll point, you tell me what to write, about ready to check. Austin, you ready? I'll point, you tell me what to write.
One,
1,
4, 1, 4, 11, 44,
Ooh,
43, 172,
yeah,
and then 174.
there you go. So we've got our answer if we want to write it, but I want you to also see that this is a tool you could use in lieu of doing normal substitution. Like for instance, if the problem said, if this was your function and it just said, find f of 4, it doesn't mean you have to do substitution. That would have been a bit of a pain. Right? Forget about division for just a second. If I had just said find f of 4, I would have done 4 to the 4th minus 3 times 4 cubed plus 7 times 4 squared. I'd have to do 4 to all those powers. But notice, if I just do the synthetic division, whatever I get at the end, that's also f of 4. So it's a lot less work to get that. We actually, when you only want this, we call this synthetic substitution. So in lieu of subbing in a 4, if we're only using the division to get the remainder, it is called, we call it synthetic substitution, because I don't really want the quotient. Okay, if I want it. But if I want the answer, it's going to be x to what power? Cubed. X cubed plus x squared plus 11x plus 43 plus remainder of 174 over x minus 4. Okay. And that is called the remainder theorem. So we're going to write that down real quick. So the remainder theorem says this, remainder theorem. If you are, when dividing a polynomial function f of x by x minus k, so we would have f of x is a polynomial divided by x minus k. The remainder is f of k, always. The remainder is f of k. So you'll see, you'll get some problems that may say find f of k. Well, you can just do division and get the remainder. Okay. One more concept and then we're done. You can work the remaining 50 minutes or whatever it takes us, okay? One more concept. All right. Do 8 divided by 5 for me. Write your answer. And write it equivalent. It should be quotient plus remainder over divisor. It should take you 2 seconds. Okay, what do you get? 1. Yes, 1 3/5, 1 plus 3/5. Very good. All right, do this one for me. 8 divided by 2, write your answer. All right. I'm doing this on purpose, okay? So Colton, 8 divided by 2 is 4, but what do we not have? Remainder. But notice what that means. When there's no remainder, the remainder is 0. Notice 2 and 4 are what of 8? Factors. Not multiples would be like 16. You got the right idea, just the wrong word, right? 2 and 4 are factors. See, look, if I cross multiply now, 8 should equal to 2 times 4. So anytime the remainder is 0, what you divided by and your answer are factors. If the remainder is 0, then what you divided by and your answer are factors. Notice up here, I divided 8 by 5 and we got a remainder of 3. Notice 5 is not a factor of 8. Okay. All right. But here, where there was no remainder, what we divided by and our answer were factors. So we want to take that concept and relate it to what? Polynomials. So if I take f of x and I divide by x minus k, and our remainder is 0, then that means our answer should just be what? If I do f of x by x minus k, what's the only thing what's the only piece of the answer I should have? When you're dividing, remember the very first thing I showed you today, when you divide, how do you write your answer? It has names. Quotient plus. So if there's no remainder, you don't have the remainder over divisor, you just have the quotient. Right? Quotient's your answer. So look, if there's no remainder, then what do you know about x minus k and the quotient? These two should be what? No. Go back to my point. Look right here. This problem is the mirror of this problem. I divided 8 by 2 and I got 4, no remainder. This is the divisor, this is the quotient. What do we know about 2 and 4? 2 and 4 are factors of what? 8. Go to f of x. I divided by x minus k. I get no remainder. What do I know about x minus k and the quotient in terms of f of x? That's exactly right. So, f of x, so if this is what happens, if the remainder is 0, so f of x has x minus k times the quotient as factors. That's what that's called. Look to the title of today's lesson. Factor theorem. That's your factor theorem. I want somebody to connect one more dot. There's one more thing you can tell us. Connect one more dot. One more thing you can tell us. This would be beautiful if you know it. Yep.
When you make x equal, or sorry, if make y equals 0, so right? If you input it like,
You gotta be a little bit more specific. You're warm.
yeah. I'm trying to find words.
If the remainder is 0, what also equals the remainder from what I just taught you? What's the remainder from the remainder theorem? Go to your remainder theorem. What's always the remainder? If you're dividing f of x by x minus k, what's always the remainder? F of k. So, if the remainder is 0, we know that f of k equals 0. Thus, this is what Haley was trying to say, thus, k is an x-intercept. That's exactly right, because f of k is 0. That's what an x-intercept means, okay? Or, it's a solution, if you look at it that way. So, there you go. All right, so now let's put this into practice. See if it all makes sense. So let's say we have x squared minus 5x plus 6 divided by x minus 3. Go ahead real quick. Takes 2 seconds. are you gonna divide? Synthetic should be done in 2 seconds. I hope the remainder is 0, otherwise I messed up. Okay, got it? Ashton, what goes outside the little house? No? Mm-mm. With the 3, I'm doing synthetic division. What goes on the inside? 1, -5, and 6, put a line, put my half rectangle here. I'm hoping, my plan was that this right here should be what? All right, so let's see. 1 and nothing,
1, 3, -2, -6, 0.
what does that mean? Now that means our answer is just what?
X minus 2.
X minus 2, there's no remainder. Now I want you to see, look at it like this. In an equation, this is a true statement because this only equals x minus 2. Notice if I were to cross multiply, I could say that x squared minus 5x plus 6 is x minus 3 times x minus 2. Thus, by division, I have done what? Factored it. By division, I have factored. Got it? Make sense? Were you okay or?
Oh, I did long.
Oh, okay. That's why they call it long division. You prefer long division? Some do. I will find that usually about 20% of the class likes long division better than synthetic. It's okay. I mean, it doesn't. There's some people, if they see it better, they like better to do it that way. But I want you to understand what all do we know. If the remainder is 0, then what you divided by and your answer are both factors, because notice I just went one more step and showed by cross multiplying. What is this guy called in the division terminology? Divisor. What's this called? Quotient. So notice what I said. If you divide and you have no remainder, it's just your divisor and your quotient. That's why I put this. This times this are factors. Okay? What else do we know? Something else you know. Again, this was where the extension that I was given to you. What do you know? What's that? Well, not K. Be specific to this problem. What's our K on this problem? No, it's not -3. It's 3. Not a y-intercept. It's an x-intercept. 3. The input of 3 to this gives you an output of 0. That's an x-intercept. That's also called. If I set this equation equal to 0, I know that 3 has to be an answer. Well, now you can look, you know what the other answer has to be? 2. So not only is this an x-intercept, you could also call it a solution. You could also call it a root, right? You could also call it starts with a z, 0. All those are true, but that's only if the remainder is 0. And so that is f of 3. F of 3 is 0. Understand why it's an x-intercept, not a y, because it's, there you go. Nothing more what I teach you today. That's it. Got it? Now you can go in, surf around in 2-4. I think you can get most of it done. I'm going to stop that 46 minutes.